is the equation. All the lines is the equation, this one. What you need to do is you put some value on it to obtain A equals to something and B equals to something, and you can obtain the result. You can know all, you can know exactly what the line is, right? But you tell me nothing if there is only X, Y, Z. You don't know the value. Are we still recording? No? No battery or something?
没有记忆体的，
What?
我手机这里都
So, okay, I will give you 5 points because I haven't teach you yet. Now, I am trying to answer this question. What is this looks like? And the topic of this is our next topic. This is the wave equations. Okay. What is E looks like and what is X? What does E and what does H looks like? Okay? This is why we are doing this. Okay. So more math. Maxwell's equations. As I said, I will use Maxwell equations again, and again. Okay. So we try to solve the equations we try to solve E and the H from Maxwell's equations. Okay, this is what we are going to do. So first of all, you have the textbook and you have my PowerPoint. You can download it from the website, but I will do that. It will be easy. Okay, from here, first of all, if there are no source, if there are no electrical source, there's no magnetic source, what happened? Question, somebody? Okay. Which one is zero? Just tell me. Erase it. I will give you maybe 5 points, 5 points, 5 points. Erase all the source part. Yes. Yeah. And what else? Not yet. Source. One more. For the third equation. Yes. 5 points. Just remind me later to give you 5 points, okay? If there is no source, our Maxwell's equation becomes this one, okay? Next question. What if we know the materials? Also 5 points. What else we can change this equation? Just leave the opportunity to someone who haven't get a point yet. If we know the material, we know epsilon and mu of the material. After we know this one, can we simplify then these equations? Can someone help me to change these 4 equations if we know epsilon and mu? I want to simplify these 4 equations. 5 points. Come on. You already got a point. Someone else. 5. Do you want to know? Too easy, right? 5. Yes. Come here. Yeah, I try to encourage you to participate in class, not just sit there. You learn little if you just sit there. You try to participate everything will change. Okay. Do you want to erase something? We try to change something? Yes. see these equations. So this one become mu hs. And then what else? Yes. What else? No, wait. Not only there. We want the general form. What else? That's it? More. UN. Yeah, of course. Yes. Not hard, right? Just raise your hand, you'll earn 5 points. Okay. So, next term is to, you have E field left side, H field right side. You have H field left side, E field right side, right? You will feel like, oh, maybe I can solve it. What can we do? If we do another curl, and we will have the same thing to right side. Okay? Okay. So you will obtain the double curl of the E will equals to, because those are minus j omega mu, those are scalar. So it's minus j omega mu times the curl of H. Right? Can anyone tell me what is the curl of H? 5 points, come here. Anyone haven't? Can anyone tell me what is the curl H? What is the curl H? Any opportunity? Does anyone want to raise your hand? What's that? 5 points, come on. You will accumulate a lot of points if you. Do you want to try? Anyone, raise your hand. Anyone? Okay. Come here. Tell me what is this? Come here. Just show me, or you can write down. What's that? Yeah, easy, 5 points. So, right? Easy, right? So you just put this one, replace this one. So J is the square root of minus 1, right? So J equals to minus 1 times negative is positive. So this term will become omega squared, these two terms. I multiply this term to this term will become omega squared mu epsilon. Okay? This one equals to this equation. That is if you take a curl twice. Okay? This is what we are doing here. And also use the vector identity in your appendix. You know, if you take the some vector, you take the curl twice, you will have these equations. Okay? For this equation, we put this equation instead of the left side. You will see that because we already know the divergence of E is the divergence of D, if the divergence of E D become this one. So divergence D is 0. So divergence of E is also 0 because of this equation. Okay, then you just do some organization. You obtain these two equations. They are wave equations. Okay, so what you get from the wave equations, you know. You obtain an equation has only electric field. There's no magnetic field. Only electric field. Only E. You do the same thing for H. You obtain another equation. This is the wave equation of E and the wave equation of H, right? They are two equations has only E field or H field themselves. Okay. I obtain these two equations from the four Maxwell equations. We assume there is no charge. That's important. There's no source. There's no M, no J, no current. There's the current density, right? There's no current charge. There's no charge density. No charge, no current, no source. I can obtain this one. So I can know, okay, if there is an air, your E field should match these two equations. Should be the solution of these two equations. Okay? So then I haven't answered my question yet. My question is, what is the structure of E field and the H field? I will try to solve these two equations, but this guy is too ugly. I don't want to see too many variables. So I define them. I call them K squared because you have omega here. You have mu epsilon, something like twice. You like a production of two things. So I call this as the K squared. So I can change this to this form, like a 2 squared. And actually K has 3 different names. The first name of K, we can call it a propagational constant, or we can call it a phase constant, and I will call it the wave number. I will explain you later about, we will discuss more about K, wave number or phase constant. Okay, because it is very important. Okay, this is where K comes from. Sometimes you will hear something called beta. If you are from our lab, or maybe you already know, if you hear something beta, beta equals to K if this wave is in the TEM, if this is the TEM wave. You just remember this at the beginning. If this is the TEM wave, this is a simple one. If that happened, beta is our, K is our beta. This is a phase constant. You hear phase before, right? You hear phase before. We will discuss this maybe later. Okay? Okay, we'll take a rest. And try to answer question 2, okay? Our activity 2 when we take a break.